Okay, so today is 05/23, 05/23. Unless you're in my even classes, if you're in my even classes, you are on the 24th. So 23rd for odd, 24th for the even. We should be working on, I believe, page 16 and 19. 16 and 19. Those should be the pages that we should be on today. Go ahead and copy those down. And we're going to try and go through this a little bit faster because most of you understand what we're doing. All right, so 05/23. Again, if you're even classes, it's the 24th. 05/23, and you will be answering the focus question, and that's on pages 16 and 19. And we have additional practice on pages 46 and 60. And this is due when you return. So this will be Monday and Tuesday next week. So Monday and Tuesday. Sorry, Tuesday and Wednesday. I think it's the 28th and 29th. So 05/28 for odd and 29th for the even. All right, go ahead and copy that down. And don't forget, you have your quiz on these dates. Sorry, these are the even dates. Odd dates are a day sooner. All right, so let's go jump to page 16. Page 16. 16. All right, so there was a little bit of miscommunication on the printout. So this is what it looks like. Today is, again, I always put the dates here. This is page 16. And today is 05/23 for odd, the 24th for the even. Okay, how do you determine relative frequency of an outcome? Okay, we've talked about relative frequency before, and we're going to talk about other items as well. Today is, we have all these items here, and I'm going to move them up here slowly for you, and I'm going to explain them to you as you write them down. Experimental probability. This is probability based on an experiment. Your actual definition is there, but I'm going to put this in quotations here. Probability based on an experiment. For example, yesterday we did, or last class, we did coin flips, and we knew that it was 50-50. 50% heads, 50% tails. But in our experiment, not everybody got 50%. So experimental probability is what you get from an experiment. Okay? It is close to and approaches your expected or theoretical probability. Okay? Close to and approaches expected probability. That's important to know. Okay. All right. Probability is the chance of something happening, the chance or the likelihood of something happening. So, for example, the probability that it will rain today is 44%. That is based on a number of calculations and possible outcomes. So we use probability in our daily lives. Today it's kind of cloudy, it's probably going to rain, and we're looking out there like, oh, it's kind of cloudy, it's about a 50-50 chance of rain. We might not actually know. Those forecasters and weather people, they know, and they'll give us a chance of rain. It doesn't mean that it's guaranteed to rain unless they give you 100% probability or 0% probability that it's not. They give you a chance that it might or might not happen. A trial is a single event that is happening. Okay, a single event that is happening. For example, in our coin flips, I have 20 coin flips total. Of the 20 coin flips, one coin flip is considered a trial. So any single, see there is single event out of many, okay, it's part of the whole. Okay, it can be one single time. Remember that first flip you got was a heads or a tails? That first flip is a single trial. You can identify trial number 10, trial number 20, the last one, the first one, the middle one, the second one. All of those represent trials. Favorable outcomes are the ones that you're calculating. What is, when we had Calvin, his favorable outcome was a heads flip, because in his heads flip, he got to eat his Cocoa Blast cereal. An undesired outcome was the tails, because that's not what he wanted. Relative frequency, we've done this before. It's a ratio of something happening or an occurrence. So if I wanted to get heads is 1 out of 2. If I did an actual experiment and I had a ratio of 11 out of 21 coin flips were heads, that's a probability, relative frequency. And it can also be expressed as a fraction or a percentage, 50%. Okay, it's a 50% chance of happening. All right, so we'll just kind of go through this a little bit more quickly. The probability of event is the number of favorable outcomes. This is what we're looking for. For example, we were looking for heads before. So favorable outcomes, number of heads happening. It is written in this format, P, and then this is your favorable outcome. This part is favorable outcome. That is what you are calculating, okay? And it's also, and you can write that as a ratio. This is favorable outcomes. Favorable outcomes. This is a number, not a hashtag.
Sorry, I don't know how to help with that yet.
And the one on the bottom, sorry, that's Google kind of interrupting us. And this is the total number of trials. Okay. So this statement asks you, I'm going to write this down here a little bit. This statement here, let's highlight it. This is how probability is written. It's written as the probability of getting whatever you're looking for. In this case, a heads coin flip is equal to, an example, 11 out of 20. And this statement means the probability of getting a heads coin flip is, that's our equal sign, 11 out of 20 trials. Okay, that's an experimental probability. So I'm going to highlight parts of this. Probability is determined by this P. Our desired outcome, getting heads over here, and a coin flip is, that's our equal sign, is, and then whatever our outcome it happens to be, 11 out of 20. Okay, that's how it's read and that's how it's described. All right, so Calvin says, man, I'd really like to get more Cocoa Blast cereal. He's got a Cocoa Blast cereal addiction almost. It's kind of scary. He really loves his Cocoa Blast. So he decides to toss, instead of 1 coin, 2 coins. So he gets 2 coins, or he just gets 1 coin and he flips it twice. He flips one coin 2 times. And if it's a match, he gets Cocoa Blast. This is our desired outcome. Desired outcome. And if it's not a match, he gets the healthy stuff. So this is what he saw. Okay. So he thinks that he's going to get a 2-to-1 ratio. He's going to get to eat his cereal twice as much as having to eat the healthy cereal. So what are we going to do? We're going to conduct an experiment to see if it's actually true. So you should make a prediction, pause the video. Okay, what is your prediction? Okay. Do you think it will be twice as likely, or well, let's just see if it's more likely. More likely to get Cocoa Blast or not more likely? More likely to get Cocoa Blast or not more likely? Not more likely to get Cocoa Blast. Or do you think it's going to be equally likely? That means they have an equal chance of happening. What do you think? Make a prediction. Do you think it's more likely, not more likely, or equally likely? Choose one. Option 1, option 2, or option 3, and then write it down. All right, we're going to conduct an experiment. Pass out the coins. Everyone should get 1 coin. And we have one little problem here. It says insert table. Okay, we don't have it. I forgot to actually insert the table. I think that was the problem in our example in our books. That's where it differed. One of us had a table. I think it was mine, not yours. So we're just going to use this space down here on page 18. We are going to create a table really quickly. We're going to put trial and outcome. Okay. And we might not have enough space, so I might have to do this twice. So trial number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many of these do we need to have? We're going to do an experiment of 30 coin flips. Okay, we'll do 30 coin flips. So I'm going to repeat this 3 times. So it should be pretty easy. And so this is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Take a little bit of time, write out your trials, and you're going to actually flip your coin 30 times. Let's see, I'll do the first maybe row with you guys and see what we get. So I'm going to have to flip twice. So that's heads and tails. So I'm going to say no match or match. So I'm going to say, I'm just going to put an X or a dash for no match, and I'm going to put a check for match. So 1 flip, tails, 2 flips, heads, no match. 1 flip, heads, tails, 1 flip, heads, match. Trial 3, I got a match. Okay. Now, if that's too confusing for you because you have to memorize them, you can just put 2 in a row and do something like heads, tails, and the next one is tails, heads, and the next one is heads, heads. All right, and keep going. Let's see what you get. We'll count all the matches. I'll pause the video here. All right, so I did all my 30 coin flip matches. It was actually 60 flips, and we're going to see what we get. So I'm going to highlight all my matches, my favorable outcomes. So 1 favorable outcome, 2 heads heads, 3 tails tails, 4 tails tails, 5 heads heads, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Do I have any other ones? I don't think I see any other ones. That's quite a nice match. So I'm gonna write this as my result here. And since I don't have a lot of space, I'm gonna put it off here to the side. Move this out of the way. And we're not gonna combine our class data because it should mimic something close, and we can kind of make a prediction. Our probability of getting a match. Probability, doing this off the side because I don't have a lot of space, of getting a match. That's what we're wondering about. That's what he gets. That's what Calvin is looking for, is 15 out of 30 trials for me. Yours might be close, it might not be close. So based on the probability, we got about half. It's just about this, not about, is 50% chance. Now, was the chance of getting a match and a not match different? No, they were the same. And some of you might have noticed earlier, you can get heads, heads, tails, tails, heads, tails, or you could have gotten something like I did, and probably you too. You can get tails and then heads. Oops. Tails and then heads. Since the order is not going to make a difference, there is another possible outcome. It could be heads, tails, or tails, heads. Both of those are non-matches, and they're just in a different order. Okay. All right. So that is 1.3. All right. Let's do this last section, analyzing equally likely. How can you determine? Sorry, let's put today's date. We are on page 19. Okay, this is your other AFQ, and today is 0, 5, 23 for the odd, 24 for the even. Okay, and this should match our other pages. All right, so equally likely means that all events, or sorry, all outcomes have the same, which is our word for equal, chance, that's probability, of occurring. Occurring means to happen, that's an outcome. Okay, you can think of this as and you'll usually see this word fair coin or fair dice. That means it's not weighted. They're not cheating in any way, sort, or form. Okay, so we're just going to say that each outcome has a same chance of happening. Okay, so there's a story about Calvin and his coins because it landed on health nut flakes so many times. But what you'll notice is in some of your experiments, you have similar results. You'll have, I got 5 heads in a row or 6 tails in a row. And we know that that's possible, but not likely. And that over time, when you get more and more data, it'll come closer to the expected outcome. All right, so we're just going to decide if one of them is equally likely or not equally likely. Okay, so let's see. You toss an empty juice can. It lands on the side. That's one outcome. It lands upside down. That's another outcome. Or it lands like it's standing up. 3 outcomes. Are they equally likely? I'm going to say no, not equally likely. Not equally likely. And we know that because, and I'm going to say this word, experiment. We know that because we did an experiment and we flipped cups and they didn't land upside down, right side up, or on its side, all the same. When we just did ends and sides, sides won out by a vast margin. Okay. Now, a baby being born, there are two options. There's a boy or a girl in this example, and those are two options. That is equally likely. Okay. So we're not going to get into conversations of or arguments of gender identity because we're just talking about them being born. Their gender identity is a personal and things that they have to identify with, and we're just talking about the biology of a baby being born. That's an equally likely event of one being your baby being boy or girl. Okay. A baby being born and there is right-handed people or a right-handed baby or a left-handed baby. Okay. This one is not equally likely. Okay. So you can usually, as a class, what we would do is we would identify the number of people who are left-handed and people who are right-handed. And just in a small sample of 30 in a classroom or 35, you'll notice it's roughly 2 to 4. Occasionally there's a few more, occasionally there's a few less. So not equally likely, and we're going to call this experience. Okay, and we know that because there are specialty stores that sell specifically to left-handed people. There are specialty items designed for just left-handed people because they are a smaller population of the general population. A high school football team plays a football game and their outcomes are win or lose. Now, a lot of people argue about this because there's two outcomes, then it's equally likely. But it's not equally likely because, so I'm going to say, no, this is skill-based. So, because there's skill involved, because practice, skill, physicality, experience, those types of things change the probability in one team's favor or the other team's favor. Okay. So a six-sided number cube. This is dice. They just don't like using the word because it's got a gambling connotation, but in case you're not sure what they're talking about, that's dice. Yes, this is our outcomes are going to be 1, 2, 3, 4, 5, or 6, all equally likely. No one number shows up more than the other if the dice is fair. Okay, and if you guess, this is the important part, guess an answer on a true or false test because you are guessing and it's not based on skill. You are not reading the question first and then determining what you think is the best answer. This is going to be equally likely. So our options are true or false. Okay. And this is equally likely. Likely. Okay. All right, we're going to stop there. And this is just a little bit of a conversation of the types of things that are equally likely or not equally likely. Your homework, again, let's go back, is on pages 46 and 60, and it should look something like this. 46 is when the boy tire maker married the girl tire maker, what did everyone say? And page 60 is this one, 54, 37. This is the, I'm not saying multiple choice, but it's a multiple answer solution section, okay? And it gives you possible choices, and this is the one that we covered, likely or equally likely, and the probabilities of what you can get out of coin flips. 50 coin flips, how many do you expect to be heads, how many do you expect to be tails, etc. Okay, go and finish those two. The last 45 minutes of class, the sub will put on the Bill Nye video, and before I forget, the Bill Nye video is based on probability, and probability has a worksheet for the Bill Nye. He is on page 90. Ooh, in your book, it's page 90. I believe it's page 90. It's right before your study guide. So look for it, make sure it's on the right page for the Bill Nye video. Okay, good. Follow along, pause and play as you go. Don't give the sub a hard time.